Hi everyone, good afternoon. My name is Eliza and I am going to host the webinar today. So, welcome to our event for today, and I hope that we will all be learning new things from our lecturer, Dr. Alex. And first, let's go ahead and have some checks here. Can anyone hear me well? Can anyone see me well as well? So please give me like a thumbs up or an okay sign if you can hear me well so that we can go on with our webinar smoothly today. Thank you so much for those who are confirming. I can see a lot of thumbs up already. Thank you. Thank you. Welcome everyone and thank you so much for joining. All right, now let's go ahead and disable our notifications so that we won't be seeing a lot of pop-ups on our screen when we start our webinar or our main topic later on. So everyone kindly go to the settings icon or the gear icon right beside the purple half circle or whatever shape it is, the purple button right beside that on your lower right corner. Please click on the gear icon. It says My Settings, and please go to Notification Settings. If you click on Notification Settings, you can see boxes in there, and make sure that the boxes are not checked. They should be not checked or disabled, just like what you are seeing on your right side of the PowerPoint slide, because it will create some distraction later on if you see a lot of notifications popping up on your screen. Okay, when you are done turning off or disabling your notifications, please say done or give me a thumbs up in the chat so that I would know that we are all good to go. All right, a lot of people are confirming now. Thank you so much, guys, for being so cooperative. Okay, now I will move on to our start of the webinar. So, our topic for today is the low voltage design, coordinating with others. And this is, yes, this is being run by Miss Alex Gregory. She is one of our lecturers at EIT, and she is also an AECOM principal engineer. Later on, she will tell you more about herself and you will know her better. All right, I would just like to address some common questions before we start so that you won't have this lingering in your thoughts as we go along the webinar, and it can make you focus more on the main topic. So about the slides, we will be sending you a copy of the slides um, in 2 days' time, and we will be also sending you a copy of the video recording for this webinar. So don't stress about taking down a lot of notes or taking pictures or screenshots, because you will have a copy of both the PDF slides and the video recording of the webinar. Also, for the certificate of attendance, we will be providing a digital certificate of attendance for free You don't need to pay for anything. You just need to register or request for it using the QR code and the link, which we will provide later on. So again, to request for the certificate of attendance, we will be providing a link and a QR code when the discussion is done. All right. And once you have requested it, it will be sent to your email addresses within the next 4 business days. The copy of the slides and the video recording, we will be also sending that to your individual emails within the next 2 business days as well. And let me also share some important facts about EIT. So, of course, EIT is an institute that is dedicated to ensuring that you receive a world-class education and also for you to gain skills that you can immediately implement or use or apply when you are already in the workplace or in the workforce. And we are also one of the only institutes in the world who specializes in engineering, and we deliver a lot of um, courses from professional certificates to diplomas, advanced diplomas. We also have higher education courses such as undergraduate and graduate certificates. We also have bachelor's and master's degree courses, and we also have a Doctor of Engineering course. We are an industry oriented school, and our programs are also industry oriented. And that is because our programs are designed by industry experts, just like Dr. Alex in here. She is one of our industry experts, and we have a pool of them who are in charge of making sure that our course materials and our curriculum is up to date, and of course can carry on and can cope with the rapidly changing technology in the engineering world. And also we also make sure that our graduates will have cutting edge skills and are valued by employers once they go to the workforce. And we also have world class Australia accredited education. So our vocational programs, as well as our higher education degrees, are registered and accredited by the Australian government. So you won't worry about the legitimacy of our courses because all of them are registered and accredited by the Australian government. And we also have programs that are also recognized by the very prestigious Engineers Australia under 3 accords. So we have the Dublin Accord, the Washington Accord, and the Sydney Accord, and they are all international engineering accords. So they are internationally recognized too. And we, as mentioned earlier, we have an industry, we have a pool of industry experienced lecturers. So our lecturers are also highly experienced engineers. You can really take insights from them and learn from their experience aside from what they teach you in the classroom. And of course, they are subject specialists, and the knowledge that they will be sharing to you, the skills that they will be sharing to you, are from their own experience in the engineering industry. And of course, we employ technologies that are both online and on campus, and it also enables EIT to source lecturers from a large group of global pool of experts. So our lecturers are not only coming from Australia, but they are also coming from different countries around the globe. Like some are from India, some are from the United States. We also have lecturers from Europe and um, a lot of continents as well to make sure that you are exposed to different phases or different facets of engineering in the whole world. And we also have a unique delivery model. We deliver our program in a unique delivery methodology. And of course, That is the use of our live and interactive webinars. And we also have, again, the international pool of expert lecturers that we are very proud of. And we also have dedicated learning support officers. So aside from our academics team, which are our lecturers, we also have dedicated learning support officers who would serve as the go-to person of our students whenever they need support all throughout their studies, be it a concern about their schedules, or be it moral support, or anything that concerning their studies. Our learning support officers will be there to give them options and will be supporting them to their success. Also, we have state-of-the-art and hands-on workshops that we provide our students. We have workshops that are going on for our on-campus students. These are face-to-face workshops, but we can also provide workshops for our online students or remote students through our remote laboratories and simulation software. And that is all about EIT. I hope that you would remember those. And if you plan to study at EIT, we can ensure that you'll be taken care of and it will be of a high quality education. And now, so much about that. Let me go ahead and give this to Dr. Alex, and she will now introduce herself and begin the lecture. Thank you.
Thanks, Lisa. Hi, everyone. Welcome to our webinar today on LV coordination. As you can see on the slide there, I am an electrical engineer in my normal job. I work at a company called AECOM, and I've been doing that for almost a decade now. So I work mainly in low voltage electrical design within the building services industry. So I am a chartered engineer here in Australia and registered within my state and across the nation under our various registration processes. So thank you very much for joining me today. Today's webinar is about coordinating from the perspective of electrical engineers. So there's a lot of lessons learned through this. So it's a pretty straightforward agenda. What we're going to do is just give a quick overview of electrical design and all the things that can encompass within our, scope. Then what we're going to do is actually run through the interface of electrical engineering design with every different discipline that you might come across. And with each of those different disciplines, we're going to pull out what we see as the common areas or areas where we don't interface very well with those disciplines. So for those of you who might work in design, or you might work in construction or manufacturing or even maintenance, all of these interfaces would still apply with other disciplines. So let's get started. First of all, we're going to have a quick overview of the electrical design process. So on this slide here, this is everything, and it's not an exhaustive list, that relates to electrical design. So first of all, we have infrastructure. So we're talking about your large electrical equipment. This could be substations, it could be your main switchboards down to distribution boards, your plant rooms associated with those switchboards, as well as all of your cabling to make that work. Now, as part of our electrical design process, we then calculate what our electrical load is going to be. And for those with an interest, there's actually an EIT guest webinar exactly on load calculations next week, in fact. So that's what our load calcs are. We're also responsible for designing the spaces that our infrastructure goes in. So we've mentioned substations, but you can also have plant rooms, you may have distribution board cupboards, or other areas where you're needing to place your equipment. We have to document how power gets around a building. So we call this reticulation. Now you may reticulate power using cabling, most commonly, and that cabling can be installed on a various number of items, such as your cable trays, or you could have cable baskets. You may be putting cabling within conduits, either above ground or below ground. Now, in this process, once we've worked out what key infrastructure we have, the load we expect to see, the space that's needed, and how we reticulate power between those spaces, we're then able to draw or design what we call our skeleton single line diagram. So this is just a very high level single line diagram that shows the basics of your building. So it seems like a lot, and that's everything to do with your big infrastructure. The other things that we do as part of the electrical design is all of the final fit out items. So where do you want general power? These are power points. Maybe you need power for specific equipment like mechanical equipment. They might have fans or aircon, or you could be supplying power for other services like fire or communications. We have to document all of that. We also have to do all of the lighting design. So internal lighting, external lighting, as well as how those lights are controlled. Once we know our final power and lighting, we can then finalize our maximum demand, finalize our single line diagrams, which is essentially the design of our switchboards, and then our containment. So again, containment is your cable trays, conduits, cable ladder, however you're getting your cabling between your equipment. So that's the detailed design phase. Now, outside of that, as electrical engineers, we also can be involved in some other aspects of a design. So lightning protection is a big one. If there is a requirement to have a lightning protection system, we will design that system, and it will be a bespoke solution for that building. We might get involved in nurse call if we're doing a hospital or a healthcare project. We always do the exit and emergency lighting design as part of our normal lighting design. Electrical might also encompass communications and security, or even dry fire. Sometimes they're separate, sometimes they're combined, and various other details. So the reason we need to know what's in our responsibility is because all of these items need to be coordinated with other disciplines. And that's what we're going to be talking through today. So let's talk through each one. Starting with coordination in general. So who do we need to coordinate with? We need to coordinate with everyone. When you look at all of the building services disciplines within a project, electrical typically interfaces with the most. So we have the most work to do when it comes to coordinating. So on the slide here, we've listed out everyone we need to liaise with. We need to talk to our mechanical engineers, our hydraulic engineers, fire, communications, and AV, so audio visual, if that's a separate person or company. Security designs, vertical transport, so lifts, escalators, cranes, as well as other services like acoustics, or structural engineers, or even other non-engineers such as the building certifier. We need to coordinate our design with all of these parties. Now, the challenge for us is not only do we need to make sure everything is coordinated, but we start doing that process at the beginning of a project. So at the very start, when we're trying to size our infrastructure, we need to know electrical loads. So to do that, we need to ask for that information up front. which can be hard because mechanical might not have made their selections yet. So we're asking for what their loads might be and where their equipment's going and how they're reticulating things around the building. So what ends up happening is we learn a little bit about most services, because we're often, as the electrical engineers, the first to start, because the question always is, what needs to go into this building? What is the power requirement? Do we need a new connection? Do we need a substation? Do we need to allow for an upgrade? So we answer all those questions at the beginning, but then we're often the last to finish our design because we need to then make sure at the end of everyone else's designs that we've got power and lighting covered to where they need it. So we are the key interface out of all of those disciplines. Because if something is missed at the end of the day, if a pump arrives on site and there's no power point there for it, it's the fault of the electrical engineers. So we need to make sure that we have covered everything across all disciplines. So let's start with mechanical. For mechanical, they may have mechanical switchboards. So in this single line diagram here, what we've got is a supply coming in to a switchboard that has 3 mechanical chassis. And we can see here that we have 1, 2, 3, 4, 5, 6, 7 mechanical switchboards. So in this project, we need to provide a cable and a circuit breaker supply to every one of those switchboards. So we need to know the load of those switchboards. We can then size our cable and our protection. We need to tell them what the fault level could be because it's based on our switchboard upstream. We need to know if they've got any emergency services that need special treatment, like fire-rated cabling. And we need to coordinate where are their mechanical switchboards going and where are our electrical switchboards going. Are we sharing spatials? Are they having their own dedicated plant rooms? They might have various control panels located around for bespoke equipment that just need a power point. We need to know, are we going to meter their power supply to these mechanical switchboards? Or have they documented meters in those switchboards? Because there's no point in paying for double metering, but we need to make sure it's one or the other. Now, a big interface point for us is the mechanical or the building management system, BMS. So this is what monitors your whole building. And this goes both ways. We might need their BMS to help with our design. Maybe it controls lights for us. And it could monitor things in our switchboards. It might monitor our battery supplies, our UPSs, or the status of our generator and fuel systems. We might export what our meters are showing to the BMS so it's all in the one system. So we need to hash that out to work out what that looks like. And also coordinate in sealing. Now this goes for most disciplines, so you'll see this one pop up a lot, but there's only limited space in a ceiling, and in that ceiling you need to hide all of your services. So you need to hide your mechanical ducting, your electrical cabling, your light fittings, your hydraulic pipe work. It's all above the ceiling, so we need to make sure we've got enough space. Some other bespoke things that might come across, combined services panels. So maybe you've got something special like a workshop or a lab or a fume cupboard, and we want to put both electrical services, so some power points, and some mechanical services, like some gas, on the same panel. Well, we need to check who's documenting that and what does that look like. There might be a fume cupboard provided by mechanical services that we would need to make sure has appropriate power supply. If we're installing a generator, we need to let mechanical know because they'll need to look at what ventilation is needed, how to extract the heat that gets pushed out into that generator room. Similarly with Fuel system supplies. Do we have ventilation for any fumes and appropriate exhausts? They might also want to know, when they're designing their ventilation or their air conditioning systems, how much heat is expected to go into that space based on our equipment. So if we've got a generator, that's going to produce a lot of heat, as would a transformer. Even switchboards and UPSs do as well. So in that case, mechanical need information from us to inform their design. You might also have pneumatic tubes, which is those systems typically in hospitals that pass samples around. Other alarm panels that may or may not need electrical services within them. And our ceiling layout. So again, this is a multidiscipline coordination item. When we say ceiling layout, we mean when you look up at a ceiling, you might see lights, you might see mechanical extraction fans, you might see AV speakers, you might see cameras, you might see sensors. All of those items need to be coordinated on the tiled or the plasterboard ceiling to make sure that they don't clash. So this one is quite common. So the common areas or things to check when we're talking about mechanical. The biggest one is your electrical loads. So we need to ask mechanical at the beginning what their loads might be, and then we need to check what those loads are at the end. Often there is a discrepancy between those two because it's very difficult for mechanical to estimate early on what their loads could be. So that's number one. Other things we need to check is their switchboard design. Because we are supplying power to their mechanical switchboards, we need to tell them what their fault level could be because it's based on the supply upstream. BMS, that's just making sure we capture all of our building management system points. So if we have meters, have we told mechanical to monitor our meters, for example? And lastly, and this is also fairly common across disciplines, is your terminations. So if they have a pump, do they need a power point, or do they need an isolator? Or do they need a cable that is hardwired into their control panel? So that nitty-gritty detail we need to run through. So that's mechanical. There's a fair amount there. If we look at structural, now structural is often overlooked. There is a fair amount of coordinating that needs to happen between structural engineers or structural installations and electrical. The first one being penetrations. You can't just penetrate anywhere in a structure, especially if that penetration is expected to be quite large. So if we need to run cabling through something, especially if it's a beam or a column, we need to consult with our structural engineers to make sure that that's going to be okay. They often also need to know the weight of any equipment we're putting in if it is exceptionally heavy. So batteries are very heavy. If we have a normal office building and we haven't told them that we're putting in a large quantity of batteries, the floor might not be rated to take that load. You might also have very heavy equipment, like a transformer. So they need to know if there's any large equipment with weights going on their floors, or even being suspended if you're planning on hanging something from a roof, like a light fitting or a cable reeler. They need to know to make sure the roof is designed properly. The next big coordination is lightning protection. So what you can see here is a typical detail that we use for lightning protection. In this case, you've got what's known as a terminal on top, which is a metal rod, a structural steel column, and then you've got a pile cap and a footing. So often for lightning protection, we use the building as part of the lightning protection system, if it's metallic. But to do so, it needs to be connected together. So we need to coordinate with our structural engineers to see if our structure can be used in the first instance. And if it is, we need to make sure that all our bonding is done in their design. So what I mean by that is to get that continuous path, we need to bond between all our metal components. So is the roof metallic? Are the columns structural steel, or are they brick? We need to bond the reinforcement in the slab. So we need electrical contractors present before they pour the slab. Same with your pile cap and your footings. So there's a big coordination piece between those two trades. The next one we have here is trenches. So maybe, and you can see here in this picture, you have a trench under your switchboard and under your transformer. The design of that trench needs to be structurally sound. We need to tell them how wide and deep that trench needs to be. Maybe we want them to design that lid as well so that it sits flush and is strong enough to take a certain amount of load. Or maybe we get structural engineers to design the supports across a trench to suit a particular type of trench lid. So trenches need to be coordinated. You could also have something as simple as a plinth, something that your switchboard needs to sit on. So if we have a switchboard outside, we might want a plinth for that, and we want that designed by our structural engineers. Or if you have an oil transformer that could leak, maybe you want them to design a bund for the room that goes around the room. So they're the most common coordination items between electrical and structural. Some other ones to run through. Maybe we're casting in conduits into their structure, so into the slab and the ground. That could be for something such as a floor box. We simply take a conduit to it. If you live or are doing a project in an earthquake area, you might have to design seismic restraints. Now what they are is, you can see them here. Imagine this is ductwork. It could be cable tray. And you have all of these lateral supporting wires that prevents that from falling down in an earthquake. That needs to be done by a structural engineer. We also use structural engineers to design the footings for our light poles. So if we have an external light pole, we ask them, based on conditions, to do the design for that footing. Maybe we need, similar to a trench, a really large pit. As electrical engineers, we don't design that pit. We need someone to design that so that it doesn't collapse. Similarly, if we're putting equipment, we've mentioned on a floor or suspended in the ceiling, but what if we're putting equipment on a roof, such as solar panels? Similar to everywhere else, the structural engineers would need to know the weight of that equipment and how it's being fixed to the roof to make sure it's strong enough and it's not damaged. So, key items that go haywire. Lightning protection is the biggest one. That's the most common point of interface, and the reason that it's a common error or an area to check is because of the timing. We need, before the footings are poured and the slabs are poured, to check that we have our bonding done correctly, because it can't be done after the fact. So there's a time limit. Similarly to penetrations, if we have something that is precast, so it's poured off-site and brought in, if we're needing penetrations, it's better to get them done and designed off-site when that is built, rather than having to do them on-site in situ. And the last common one is bunding. When we ask for bunding, such as those oil leaks in a substation, we need to let the structural engineers know, is it temporary, meaning it can be removed, or is it permanent? Because there's nothing worse than having a permanent bund installed in front of something like a doorway where you can never roll equipment back in or out. All right, next discipline is fire. So typically this is fire protection when we say fire. So this is where we've got things, they provide fire indicator panels, pumps for sprinklers and deluge systems. So it's quite similar to mechanical in that we need to know where their equipment is so that we can provide power to it. So unlike mechanical, who in a larger project would have their own switchboards, everything for a fire system is typically supplied by the electrical switchboards. So we provide power to their fire indicator panels. So to do that, we need to know where they are, what the load could be of that panel, and we need to tell them, similar, what their fault level could be so that they can then specify an appropriate FIP, fire indicator panel. The other big item is they often have pumps. So you can see here these pumps in a sort of shipping container style. So the pumps can vary. They can vary in size, in power. They might be diesel, they might be electric, they might be both. You could have a main pump as diesel with a backup electric, or vice versa. You might have two pumps, yet they're duty standby, meaning only one pump is used at a time. So we need to know that information because when we're working out how much load we have, it's important to know if we can see both pumps running at once or if it's just one then the other, because then we can halve that load. And things like pumps, especially fire pumps, can have a very, very large inrush current. So we often need to know what that pump specification is so we can make sure our circuit breaker isn't going to nuisance trip. So you can see here on this diagram, as an example, you could have over 500 times the full load current of that pump at your initial speeds. So we just need to make sure, because often those pumps are associated with really important systems, and the last thing you want is for that pump to try and start and for your circuit breaker to trip the circuit. And lastly, you might have what we call life safety. So anything that comes out of AS 3000 or in Australia, the Building Code of Australia, that is a life safety or an emergency support system, because there's certain requirements that we need to do, such as fire rated cabling, to make sure that they have continuous power available. Now, some other basic things, fire control room. Maybe there's enough equipment that they have their own fire control room. So we need to fit out that room with power, with lighting, with emergency lighting, all the basics that we would in a plant room. The other common one, which we've already mentioned, is ceiling coordination. So they might have smoke detectors, for example, and we need to make sure that they don't clash with our light fittings. And maybe they have other systems such as gas suppression. So similar to any equipment, what equipment do they have? Where is it going? What power supplies do they need so that we can document that in our drawings? So common checks. Is it a safety service or not? Because we would treat them differently. So not all pumps and not all equipment is a safety service. If they do have pumps, are they diesel or are they electric? Because there's a big difference for us in what the load is between those two. And in general, what equipment do they have and where is it? Often there's a lot of small equipment that can get missed that simply just needs a power point. So it's that final interface that we need to run through. All right, next up, VT. So this is vertical transportation. So say you've got a lift. What's an important question is, well, does that lift have a motor room? Is it a machine room-less lift? Do I provide power to the top of the lift or do I provide a power supply to the bottom of the lift shaft? We need to also check our cable sizing. So similar to fire where we had to make sure our circuit breakers were correct, we want to make sure our cables are large enough, especially our earths. Or maybe we need fire-rated cabling, which again is that question of, isn't a lift that's used for an emergency supply? We also need to tell the lift or the VT designer what the fault levels could be, same as every other discipline. They need to tell us their loads. Whether it's a lift, it could also be a crane with the same questions. Where do you need your power supply? How big? It could also be a vehicle hoist. That still falls under VT. Or escalators, also part of VT. So all the same questions are asked, but we just need to make sure that if we have escalators, hoists, cranes, or lifts, that we talk to the vertical transportation team. So the common questions: where do you want your power? Seems straightforward, but some lifts might even be hydraulic and they don't need much. Maybe they're electric. Maybe we run power to the top of the shaft and not the bottom. And the big one is, what happens in an emergency? Does that lift need to operate? Does it need to be isolated? Will it return to its safest level because it has its own battery backup? Or do we need to provide something that will allow it to safely lose power? So that's a big question. All right, ICT. So ICT, which is our communications, it could be part of us electrical engineers' responsibility, or it could be separate. Now, you'll be seeing a theme with all of these coordination dot points, which is good. The theme here is, what equipment do you have? What load do you need? Where is it going? So in this case, you might have communication racks or audiovisual racks or equipment. So what load do they have? But you also might have some bespoke things. So we've mentioned AV, but you could have nurse call. We could have, if we're documenting it, combined layouts. So we might show power at desks as well as data points. Things that are typically specified in the ICT world could be what projector you're using or electronic whiteboards, CCTV locations, and backup power. So because comms often is very important, we need to have a discussion around what happens during a loss of power. Can their equipment go down? Are they providing their own backup battery within the racks? Or do we need to provide a UPS supply? Do we put it on generator or not? How important is it? There's a few questions there to ask around that scenario of loss of power. And lastly, monitoring points. So is there anything that we need to monitor of theirs or they monitor of ours? Such as we might put a meter to measure the load of their communications racks. So if we just have a quick point at our pictures here, this is some typical comms racks. This could be a combined power and data desktop outlet, and this is just a nurse call system. So we've mentioned UPS. Maybe we need to provide a UPS, being an uninterruptible power supply to their equipment, or maybe they are. For the comms racks, again, how many supplies do you need? What loads? Do you need us to do any special earthing for you, which we call a common earthing terminal? Maybe they have anti-static flooring that we need to provide. Similar to mechanical, we could have a combined panel. So if there's a combined panel here that has multiple disciplines on it, including mechanical, electrical, and ICT, what goes on that panel? What's the layout? And who documents it? Someone needs to take responsibility for that medical panel. Same with labs. For lighting control, maybe we need to coordinate with their AV system so that we can have a special setting to go into, say, a presentation mode. Up here, you'll see a good picture of what we were talking about for ceiling coordination that applies to all the disciplines. So we don't want our lights to clash with our mechanical services. You might have sensors, or you might have sprinklers, and they all need to have their own position in the ceiling to make sure that they don't clash with one another. And our floor boxes. So we've mentioned conduits might be in a slab, so that's a discussion with the structural engineers. Then you might have power and data in the same box. So similar to our medical panel, we need to iron out who's documenting what and what that looks like to make sure there's no gaps. So the most common checks are those combined items, so service panels or floor boxes or switchboards, and what happens in an emergency. So just like VT, we need to make sure we've covered that emergency scenario. All right, security services. Again, sometimes this is covered by ICT, but what we're talking about for security really is security panels, CCTV, other things that might be boom gates or similar, security gates, sliding gates, and some bespoke equipment. So they've still got things like key safes that might need a PowerPoint. So we need to talk to security services about what equipment they have, and this is just a few examples so that we can coordinate power to those items. So the common things to check for CCTV, do they actually have a certain requirement for lighting that we need to provide so that their closed camera TV can capture images correctly? There might be a minimum amount of lights that's needed. How are we getting power to islanded items? So for a security gate, we would need to know where it's going. We would need to install underground conduit with power out to that location and turn that conduit up at the right spot. So there's a lot of in-ground coordination for anything that's outside the building. And another important but common interface point, same with ICT, same with vertical transport, is what happens in a power failure and what do you need us to provide? Okay, hydraulic. So hydraulic services cover your cold water, your hot water. Sometimes they also cover gas. So this is very similar to mechanical. So the things that we've already spoken about is your load. What equipment, where's it going? Single phase, three phase. Do you want an isolator or do you need a power point? How does your equipment connect to a power system? Or do you have a control panel, so you just need a cable? So they will tell us their equipment and the load, we will tell them the fault level, and we will provide a power supply. Now they might also have other hydraulic equipment. There's a whole range, but things such as trap priming devices or TMV monitoring might need a power point. When it comes to hot water systems, maybe we need to provide a meter to monitor the load of that hot water system. Or maybe we need to provide a time clock control so it only turns on and off at certain times. There could even be the scenario where all three disciplines need to coordinate. We provide a power supply that's controlled by the BMS, which is mechanical, that services a hot water system by hydraulic. So in that case, all three disciplines need to coordinate together to make sure we have that covered. Now, other items, just to give you a bit of knowledge of what is hydraulic services, are listed on this slide. So hydraulic are also potentially responsible for drinking fountains, any washer or sanitizer, especially in a hospital or a kitchen. They document eyewash safety showers, so maybe you've got a lab or a workshop. They provide their own meters, but only for water, not for electricity. There might be requirements in your country, like there is in Australia, for metering of certain things. that hydraulic are to provide, yet because it's metering of electricity, we provide it as electrical engineers. They provide hot water. Now there's various types. You could have gas hot water, or you could have a fully electric system. Hydraulic also can document irrigation. Maybe you're doing a sports oval or a stadium. Hydraulic engineers get involved in irrigation, which often needs power because you've got sprinklers and timers and pumps. Or you could have something beautiful like a water feature that still has the same components: water supply, timers, pressure valves, pumps. All of those items need to be provided with power, which is us. So tricks and traps. Don't forget all the random devices that could be by hydraulic, including trap primers and urinal flushes and all of those things. We need to know what the load and the diversity is, because a lot of the time hydraulic equipment isn't used all the time. So irrigation, for example, could be used once a week. Now, sometimes there's confusion over what the architects specify on hydraulic engineers. So a common one is sensor taps or hand dryers. So we might not see them on the hydraulic drawings because they're provided by architects, or vice versa. There's a little bit of cross-discipline there. And lastly, because hydraulic is associated often with water and wet services, we need to make sure that when we do provide power, it's the right IP rating so that it can go in the right zones near a potential water source and remain safe. All right, lucky last is civil. So civil is typically external. So what we're talking about is trenches in terms of this type of trench, in-ground trench. So when we're running cabling and conduits, we coordinate where our trench runs are, and we make sure we have appropriate segregation or space between different disciplines. So we need to coordinate any in-ground works that civil are doing, which could be other pipes, to our electrical services. Because they're going in ground, we need to make sure we've got sufficient cover between our services and the finished level. So that means talking to civil to make sure that there is enough ground cover. They often document everything very specifically with a surveyor, like what this guy's doing in this picture here. So civil may or may not want us to document specific eastings and northings or specific locations of every pit and conduit run. Whether it's new or demolished is important to understand in terms of in-ground, because maybe we're abandoning services in-ground, or maybe we're pulling them out. And civil is also very familiar with the soil conditions. So we need to know that for our earthing design, more so for high voltage, but it plays a role in lightning protection, such as our earth resistivity values. How conductive is our soil? Now, they also get involved in things like pits, similar to structural engineers. We need to look out for their roadways and vehicle access to make sure, for example, our pits have an appropriate lid that can handle the weight of the car. What the finished surface is, so we need to know if we're dealing with grass or if we're dealing with concrete. Where can our pits drain to, because that's important. And making sure we're not putting anything that is in a potential flood zone. So civil engineers do the flood mapping often, and we need to make sure we're not putting pits in those locations. So the most common question is, are we talking to the civil engineer or the structural engineer? Some things do cross over, such as concrete plinths, slabs, pit designs, bunding, trenches. So we need to make sure that we're talking to the right person. We also want to look at our ground levels. There's nothing worse than a pit that's sitting halfway on a slope in and out of the ground. And checking those things like flood levels and in-ground services. So maybe we need to make sure we've got really good sealing on our cabling because it's running through a potential flood zone at that depth. And we'd only know that by talking to our civil engineers. So to summarize, Electrical engineers coordinate with everyone, as you can see. You need to watch for our common mistakes or errors because coordination goes both ways. We can often provide information to other disciplines and vice versa. So check in with them, not only at the start, but all throughout your design, especially at the end, and document everything. Make it really clear where electrical stops and that discipline starts, so that when they go to where electrical stops and that discipline starts, so that when they go to price and install the works, there's no confusion or gap between the two. Thank you, everyone.
Okay, thank you so much, Dr. Alex, for your very powerful and informative presentation today. I can see a lot of comments here from our students that this is a really good presentation and topic, and they find it very interesting and they are learning a lot. So thank you so much for that. And thank you everyone for participating well and asking really good questions in here. So I would like to also share our upcoming courses that are related to electrical engineering in here. We have some courses that will start on the 6th of November. So we have the Professional Certificate of Competency in Earthing and Lightning Protection. We also have the Professional Certificate of Competency in Power Distribution and another Professional Certificate of Competency in Electrical Power System Fundamentals for Non-Electrical Engineers on the 13th of November. And these professional certificate courses don't have formal requirements because they are designed for professional development. So even if you don't have much background in electrical engineering, you're still welcome to enroll or register for those courses. And for those who would like to take on a higher education journey, we have our graduate diploma of engineering for electrical systems on the 2nd of January and a master of engineering electrical systems online on the 2nd of January. And we have another professional certificate of competency in substation design main equipment on the 16th of January, and another one on the 16th, which is the Advanced Diploma of Electrical and Instrumentation, or E&I Engineering for Oil and Gas. And we also have a lot more like professional certificates and other advanced diplomas and an undergraduate certificate still related to electrical. And you can find out more by going to this link. We have www.eit.edu.au/study-areas/electrical-engineering and a slash. So if you go to this link, then you can find all these courses in there. All right. And we also have upcoming webinars for those who would like to still attend more of our free webinars. So on the 18th of October, we have another low voltage design webinar, which is focusing on maximum demand. We also have our virtual open week on the 23rd of October. And we invite everyone to join this because we answer a lot of questions about courses, about academics in here. And we also have our study on microstructure characteristics of steel and two-body abrasive wear on the 1st of November. And we have authentication for remote critical infrastructure for IT/OT assets on the 8th of November. And you can also visit our triple W or our website events page for the other upcoming webinars. All right, please go ahead and scan the QR code here for you to be able to request for your certificates or certificate of attendance. Please note that we don't send out certificates if you don't request for it through the QR code or through the link in there. I'll be sending the link in the chat. Please bear with me. I am sending it now. So if you're comfortable with the QR code, go ahead and request for your certificates now. If you're more comfortable with the link, then please bear with me. I am typing the link now. All right, here you go. I have sent the link to request for your certificate of attendance. Is everyone all good with the QR code now? Ahura, if you cannot see the QR code, that's fine. You can go ahead and use the link that I sent in the chat. Okay. And Dr. Alex, I have one more question in here. Okay, you just replied. Thank you so much. Richard, she just replied to your question in the chat. All right. Since I am now sending the link in the chat, I'm going to go over the next slides. So I think you are done with your Q&A earlier, and you can continue asking questions while we are here in the chat. And I would like to also let you know that if you would like to know more about EIT, you can go ahead and visit our website, and that is www.eit.edu.au. Our head office is at 1031 Wellington Street, West Perth, in Perth, Western Australia. If you are in Australia, you can call our 1300 number in here. As you can see, we also have our number for those who are calling from outside the country or outside of Australia. If you have further questions or concerns about webinars, or if you have more questions later on regarding this topic, please go ahead and send them to webinars@eit.edu.au, and we will be forwarding them to Dr. Alex. And for those who would like to look at the schedule of courses that we have or the list of upcoming intakes for our courses, please go to www.eit.edu/schedule. All of our courses that are upcoming are there. And yeah, that's it. Thank you so much for attending our webinar today. We highly appreciate everyone's participation and feedback. And you're welcome. You're very much welcome. I'm Kelvin. And thank you for your feedback as well. We hope to see you all in our upcoming webinars, and hopefully some of you will enroll in some of our courses as well. Feel free to reach out to us, to me, or to our webinars email, and everything will be forwarded to the right person depending on your question. All right, I will give 6 more minutes for your questions to be answered by Dr. Alex in the chat. For those who have more questions, feel free to send an email to webinars@eit.edu.au. And again, for the recording of the video recording of this webinar, and for those who would like to have a copy of the PDF slides, we will be sending them to your emails in the next 2 business days. And if you have requested your certificate today, we will be sending that out in the next 4 business days to your email as well. And our cutoff for requesting certificates for this webinar would be on Sunday afternoon. Please make sure that all your certificate requests are in so that we can go ahead and prepare that by Monday. So I will keep on sending the link for your certificate so that no one will miss it. Thank you so much, everyone. And you're welcome as well for those who are saying thank yous. Really appreciate you all.